drill. Anyone used a drill before?
Yeah.
You all use drills, excellent. So, okay, so let's just have a look at a couple of the bits on the drill. Now, most drills have got similar bits and pieces on them. So the first thing we look at is this top bit here. We've got a number 1 and a number 2. What is that? What's that for? It is speed. It's speed. Okay, 1 is slow, 2 is faster. Generally, number 1 we use for screwing, number 2 for drilling. Okay, that's a general rule of thumb.
Is that like maximum speed that
Yes.
you can work up to, or just?
Yeah. It depends on the trigger. Some triggers get soft triggers where if you hold them in, it goes slow, and the more you put it in, the faster it gets. Some drills, depends on the brand. Okay, will be it's an on-off.
It just sets at that speed.
Yes.
Yeah.
Okay. But this will build up. Okay. Now 1, as I said, for screwing, 2 for drilling. Number 1, okay, is more powerful than number 2. Okay, it's got a higher torque rating on number 1. Right, next thing we're going to look at. In this particular drill, we've got a button side to side. Okay, what this does, if you look at the chuck, in this way the chuck is now moving, okay, from me facing it in an anti-clockwise, so it's undoing a screw. If I push this in, okay, that's the way it does up. So this was doing screws up and drilling, the other one's undoing screws. So we just got reverse. Okay, next little part we look at, okay, now some of these parts are, from my point of view, gimmicks. On here, we've got a picture of a drill bit. Can you see? Yeah? Now when we line the drill bit picture up, what that drill bit does, okay, that sets this to its maximum torque setting, so it's ideal for drilling. Yep, so we can put it on for drilling. We've then got this picture here. It's a picture of a hammer. What's that for?
Hammer drill.
It's for a hammer drill. Okay, and this is where, okay, I personally believe it's the first gimmick that we're going to come to. Okay, so what is a hammer drill for?
It's like you can do harder something harder.
Right, okay. What it does, okay, it turns it into more percussion, okay, ability on it. So as you're drilling, the drill will also go in and out, not just round. Okay, so it's for drilling some masonry. Now the thing is with a hammer drill, okay, you need a proper drill bit. You can't just use any drill bit. It's got to be a masonry drill bit. Okay. Now that works fine on what are called aerated concrete blocks. So Celcon blocks, thermalite blocks. Okay, they're lightweight blocks.
I don't know what that is.
Right. Okay. So in bricklaying, okay, on modern housing, okay, or modern masonry housing, the outside are made of bricks, the inside are made of lightweight concrete blocks. There's lots of air in it. They're quite soft. Okay. Now that will drill into that, fine. Okay. Now, if I'm honest, a standard drill bit will also drill into that. Yeah. Okay. Okay. You can just put raw plugs in. Now, if we took that into something hard, like a hard brick or concrete, okay, that's very ineffective.
It's not going to do it either. It's not going to work.
Not really. What you'll find is, if you've got plaster, you'll put it on that hammer drill. Okay. And if let's say you're doing, okay, where your window is, and you want to fix up like a blind or curve, okay, for example. If that's a concrete lintel, if you try to put that in, normally as you go in, the drill goes all over the place and just make a big hole in the plaster. Yeah, because it's not powerful enough to punch into the concrete. For that, you need what's called an SDS drill. Okay, and that will go straight in. So to me, that's a little bit of a gimmick.
So why do they put it on?
Well, because it gives you an extra selling point, from my point of
But
view.
then if it doesn't work on stone, then it's
Okay.
a
Yeah, but it'll work in aerated concrete blocks.
Oh, I see.
Okay, but then again, as I said, a standard drill bit will go into that. Yeah, right. So if we then come round, okay, we've now got all these numbers here as well. What are these numbers? Does anyone know?
Size of the drill bit.
No. Torque setting. Torque setting. What does torque setting mean?
Resistance.
Okay, resistance is exactly what it is. Okay, okay, that's a better description than. Yeah. Okay. So from the torque setting, what that means is, okay, if we go to the lowest torque setting, if I hold this and I turn this on, can you see that's doing nothing? So if I take a piece of timber, I'll take a slightly thicker piece of timber, and I'll take a drill bit, a screwdriver. If I now put this in at torque setting 1, when it gets to a certain depth, can you see the drill stops working? As I move this up, okay, I'll take it up to 3, so I've gone up to 3. Okay, that'll go a bit more, and then I'll start talking again. And eventually, as I go up through the talk settings, one more. Okay, and I keep going up. Eventually, I will find a talk setting. Okay, that will stop when the screw has finished at the point I want it to finish at. In theory, this is fantastic. Yeah, because that means I should be able to get another screw, put it in, and it will stop. So that way, I haven't got to, okay, concentrate as much on getting my screws to finish at the right point, because they should all finish exactly where I want. Now, here comes the bit that turns this from me, okay, into a gimmick. During the length of wood, okay, what that torque set is doing is, as that screw goes in, the resistance on that wood is causing that screw now, okay, the pressure on the clutch on this to release, to stop it working. Now, with a piece of timber, unfortunately, because it's a natural substance, the density of your timber can change in its length. As soon as I put that screw into a bit of timber that's a different density, this torque setting is now incorrect. So that means I'd have to physically, okay, double check every single screw I put in, which beats the, okay, takes away the purpose of this. So if we said, for example, you're going to lay, I don't know, let's say you're going to plywood over a floor because you want to finish it nicely to finish, put some laminate or tiles or whatever, and you'd have to screw it down every 150 millimetres. So we're talking possibly thousands of screws. If you set this up in the ideal world, you can go in, all your screws finish nice and flush, okay, which they should do. But because the substance you're going through or going into is a different density, as you go through, a lot of them will finish flush. Some will go a little bit deeper, which is not too much of a problem, but some will stick out. So you've got two choices. One, you put it in, check the screw, adjust this, check it. And if you're doing that, it's absolutely pointless setting this up. You might as well, from my point of view, set this on a drill and just do it all by eye anyway. The other way you can do it is go into all the screws and then go back through and adjust the ones you need to. Only trouble is, if you've got, let's say, 4,000 screws, and now you've got to look at every 4,000 screws, which ones needed to go back in, okay, you might as well have done this in the first place. So to me, this is a little bit of a gimmick.
To leave it on the drill bit.
Okay.
Is it like really an MDF thing?
No.
You know, for something that's
Okay,
consistent,
well, possibly, okay,
you know.
but even MDF's not always consistent,
Oh,
okay,
right.
it's not always, different brands and,
Yeah.
okay, different densities, okay, but yeah, it would work better on MDF, okay. Right, so let's explain the parts of the drill. Now let's get on to using the drill. A few things we're going to look at, okay. We have, okay, you saw that screw, I drove the screw directly into that piece of timber. But if I want to screw two pieces of timber together, okay, I've got, okay, a range of ways of doing this, or approaches. So what I'm going to do is, okay, we're going to do a little bit of an experiment. I'm going to just take some packers at the moment. I'm going to put some packers in that timber. I'm going to take the screw. I'm going to screw through one piece of timber. Now that screw is screwed into that other piece of timber. I'm now going to remove the packers. And what we've got, you can see we've got a gap. Okay, can you tell me, okay, what's going to happen, okay, to this gap as I do this screw up?
Well, it's tightened together, so it's going to close a bit.
Right, okay. Okay, so it's going to close up, you're saying, okay? Right, now if I put this in,
Oh, the screws are going.
but what's happening to the gap?
It's not even.
What's happening to the screw?
It's gone through the
Put it in. So it's not putting the gap up.
Oh,
So just screwing two bits of timber doesn't necessarily make them tight together.
come together. Oh.
So we need to, okay, when we're using the drill, be aware of that and actually make sure we do it in such a way that we can get the timber tight. Okay, so that's important. So a way that can be done is we can drill what's called a clearance hole through, okay, for your timber. So what we do is we take a drill bit that is actually the same overall diameter as your screw. If we then pre-drill what's called a clearance hole through your piece of timber, put the packers on so we've got exactly the same setup as we had before. And I'll put the screw in. Okay, so again we've got that same gap as we had last time. Now what happens to do the screw up?
I'm guessing it's going to close up.
You're guessing, okay? Right, as I do the screw up now, what's going to happen?
Close up.
Okay,
Uh-oh.
okay, that's fine, okay. You can see it pulls the timbers together.
So make a hole first.
Because I put a clearance hole through this, the screw is not actually cutting a thread in the first piece of timber. Okay? It's only cutting the thread in the second piece. So what it does, it actually, because there's no thread cut in this, it will pull it. If we cut a thread in this and cut a thread in the other piece, imagine if you had a bolt. Everyone knows what a bolt is. Okay, if I put a nut on the bolt, and then another nut, if I hold the two nuts away from each other, if I do the bolt up, it will turn and the bolt and the nuts will stay the same distance apart. That's exactly what's happening if I just screw it straight through. So what you'll find a lot of carpenters do, they do a screw up, they release it, push harder, do the screw up, release it, push harder, do the screw up, and they put the screw in and out, and they're relying on pressure from the screw to hopefully push them together, so by the time the screw goes in, it holds. But if you drew a clearance hole first of all, it will put it together.
Well, my dad always used to say that you should, the drill pilot hole, or I used to call it, that it was slightly smaller than the screw.
Right, what we've then got is a pilot. So we've had a clearance drill, we're now going to talk about a pilot drill.
Oh, I see, they're different. Right.
So a clearance hole means the screw will go through without actually making,
Without doing anything
without
to it,
cutting into the screw.
That's the clearance one is the same size as the screw.
Same size or slightly bigger.
Okay.
So you
Okay.
can literally just push that screw now through
Okay,
that
it's
hole.
the same size. Okay, a little bit. It's got a little bit of friction against it, but yeah, I could.
Not a lot.
Okay, yeah, but I could push it through because it's exactly the same size. So it is touching, but it's not cutting
Does
through.
that make it a weaker joint?
Depends what you're
You're
using
not
it
cutting
for.
into that
Okay, not necessarily. Okay, it all depends on what you're screwing into. Okay, the thickness of this material and what this is being used for.
Yeah.
Because potentially I could put that in, get this together. If that's touching, then I could put the screw in, because that way it will cut a thread in this. I mean, if they're already touching, that's fine. So
Oh,
if
so the
I,
first one could be that, and then you can...
yeah, I could do, or I could clamp it all together
Yeah.
and then screw it in.
Okay.
That way we'll be fine. Right now, this bit here. Okay, now this is smaller than the screw, but okay, about the same size as the solid piece of the screw. Okay, so what that will work well for, if we take a piece of timber, here, I'm going to screw it straight in. What's going to happen, okay, to this timber, okay, here, if I put this screw in here? Right, what's what happens to the timber?
Split, yeah.
The timber splits. So if we want to avoid something like that happening, what I can do is, I can take a drill bit that is, as I said, about the size of the core of the screw. Okay. If I now, okay, if I come, that's already split that one. So if I do it on this piece, because I don't want to split, and I'll come in about the same sort of distance, and I've pre-drilled a hole. Okay, so that there is a pilot hole, not a clearance. Now if I take the screw, put the screw in. What's happened to the timber? It didn't split. So what I'm doing is, okay, when I put the screw without doing a pilot, as the screw goes in, it's wedging the grain apart. And because I'm that close to the edge, okay, it means it's got a weak part, so it'll actually break apart.
So use that one when you're close to the edge of the piece of timber.
Yeah. I could have also used this to do a clearance hole, but I could have used that through the first bit and that into the second bit, if I needed to, if I was near an edge. So I need to, I do need to obviously keep my wits about me and think, okay, what is the best way of approaching this? Okay, there's no set method, but we want to get the best out of whatever we're fixing. Yeah. Now, the only thing I haven't talked about is release, is changing the chuck. Now, most chucks these days, okay, are what are called keyless chucks. In the old days, they sort of had a chuck key to turn to do it up. So what we do with this, all we need to do is turn the chuck that allows this to come out, put it back in, and then just tighten it back up. Okay, and we need to turn it, and it will lock in place. You can hear it. What a lot of people do, which you can if you want, if you so wish to, is, and what I was doing earlier, is put this in, and I physically hold the chuck and turn it, turn the drill on, so it tightens up. Now, if you're doing that, be careful, because if I hold that hard, and I pull this, okay, I can take all the skin off my hands. Yeah? Okay? So that's where we are with the actual drill. Okay? So I'll leave it there for a second, then we'll go through the other bits in a minute. Yeah? Go on.
What is the bit that's called where you get like a little dip with the hole, the pilot hole or the other hole? You create a little dip at the top so the screw head doesn't kind of...
The countersink. Yeah, a countersink. Yeah. So what that does is that produces a little bit like this, really. Yeah?
So,
okay, that's called a countersink.
Is that another different bit as
Right,
well?
let me show you. Let me move that on. Right, one of these. Okay, yeah, so what it is it's a different type of bit, and there's lots of different bits. Okay, and what we do is we draw a hole through. So if I drilled this hole, I could have taken that, and then...
So that would be like pilot and then that's all prepared already?
Yeah,
for it.
yeah. So if I put this in, now if I put the screw in, you can see...
Split the top.
Okay, yeah, so the head finishes flush or slightly below the surface. Okay, there are lots of different types of bits that you can get for doing different things. Okay, so in your toolkits, for example, okay, different types of drills. We've got drill bits that look like this, which is a flat wood bit, sometimes referred to as spade bits. Okay, so it's a different type of drill bit. Okay, now they're normally used if you want a bigger sort of like hole, rather than make this a great big solid piece of metal. Imagine, okay, which you can do. Okay, it means that also as well, if that was a big drill running down, the chances are that might not fit in the chuck, because these chucks only go up to a maximum diameter. So what
That's a drill bit.
That's a drill bit, yeah. Yep. Yeah. So if I take that as a drill bit, and you are going to be using one of these, not today, okay, but probably Friday. Okay. Yeah. Yeah. So if you look at this, you can see. Okay, you can, I didn't go all the way through, but you can start seeing it makes a bigger hole, rather than having, okay, that type of drill bit, because it means there's less metal required to produce it. So it's cheaper, it's lighter weight. It also means that it goes in the drill easier. Yep. Now using the drill, we're going to screw this together. So we want to screw this together in the optimum position. Now, what you want to do is, okay, is find the centre of this piece of timber. So the centre of this piece of timber running through happens to be, okay, measure. I'm not going to do your maths, you're going to do your maths. Okay, so if I look at that and say, right, okay, that measures this much, so halfway of that is there. I'm going to take this out, so I don't want that in position. I will then take my square, square that across on the back of your timber, because that is your centre point of this. So this would be the ideal position for your screws. Now we're going to put 2 screws in this. So we're going to measure in, okay, a sensible amount to get the most out of the screw, the holding point. So we're going to come in 25% of whatever this is. So measure that, so we do a quarter. So if I measure through and say, right, okay, I come in a quarter, do the same here, come in a quarter, and then we're going to drill clearance holes. So remember, a clearance hole, 500 metre drill bit, put that in, and through here, keep my hands out of the way, don't hold on to the drill bit when you're going through. I can drill on that line, 500 metre drill bit. Now, I could countersink it if I need to, but I'm not really going to need to countersink this type of wood. This is a softwood, okay, and we'll talk about that in a little while, unless you went through it yesterday. Because of the type of wood this is, the screw will sink into this. So what I can now do is put my drill bit in, take my piece of timber, make sure it goes in, okay, the correct way round. Okay, don't put it the wrong way. We're going to make sure this is flush across the top, here. And when that's flush, you can take your screw, okay, which I had on here a second ago. Yeah, that's why I've got it. I've screwed it into there. Thank you. Just, there you go. I can now put my screw in here because I'm far enough away. I won't need a pilot hole for this particular job. I can put my screw in, make sure this is flush. I can move my screw, okay, and that pulls up nice and tight. And then I can put my other screw in.
Where's that going into? Is it going into the little tub, or is
No,
it
no,
going into the other bit?
that's going into it's probably
It's
half.
just in the other bit,
because
yeah.
we've measured halfway.
Yeah, yeah,
It's
I
dead
can see
centre.
It's just before the tongue. Yeah.
Dead centre. If you put it in the tongue,
Yeah, no, that would...
you've got a big chance of this splitting
Yeah.
because the
Yeah.
tongue's quite small. It's a 10mm tongue.
Yeah, yeah.
It means the screw going at 5mm. If you did need to go into the tongue, which you could do, you would have to drill this bit,
Teeny, yeah.
okay, in that bit first of all to stop it splitting.
Yeah.
But going in the centre of that is absolutely
Better,
fine.
yeah.
Okay, any questions on that, people?
I might need you to walk me through it again in a second.
I can talk you through it again in a second, no worries.
Thank you.
I might need a bit of help with the
Okay, alright,
changing,
okay.
the drilling bit.
So that's it. So let's get back to what we was doing and produce all that really good work.